Hey grade 7, welcome to another edition of Mr. V Teaches Math. And today, folks, what we're going to be looking at is the volume of prisms. Not just rectangular prisms, but triangular ones as well. And so our goal today is we're going to, as often it happens in these types of things, we're going to be using various strategies to calculate the volumes of prisms. So the problem that we're working with today, the first one anyways, is that my cousin Steve works at a dice factory, and his job is to pack dice in boxes. And so he says, I have to pack dice in boxes like this one right here. And each edge of each die is a centimeter long, and if I calculate the volume of a box, I know how many dice it can hold. So the question is, how many dice can Steve fit in each box? Now you notice that there are a couple of dimensions here. It's 5 centimeters by 3 centimeters by 4 centimeters. And so we're going to go through a few steps to try to solve this problem. And what we're going to do is follow the steps. So first step that we have to do is to use linking cubes to model the area of the base. Now we're told that it's 5 by 3, and so I just happen to have some linking cubes. And I'll just create a base that is 5 units by 3 units. Now, if you count 5 by 3, you'll know that I can fit 15 cubes on the base in the base of that box. Okay, so that's our base. The step 2 is to make more layers until I basically get high enough. And so I have a few more layers to add. In fact, I need to add 4 more layers, because if we're assuming that each of these is a centimeter high, and this would indicate that this box is now half full. Okay, and I add another layer of dice. So I've now got 3 layers of dice. And this is my last layer. So if Steve is packing the dice into these boxes, he can fit this many dice. So basically every layer is 15 dice. So 15, and then 30, and then 45, and then 60 at the bottom layer. So if there are 4 layers, that means that you can fit 60 dice in here. The idea of 60 dice also means that that's the volume of the box, that the volume is 60 centimeters squared. That's how much will fit into the box. Okay, so that's a way to sort of model volume with some centimeter linking cubes. I'll just put those away for the time being. I'll move on to the next thing. Volume is always measured in the units with a little raised 3 written after them, like 12 meters cubed. This raised 3, what it tells us is that 3 dimensions are involved. We have the length, the width, and the height. Okay? Now, what we're going to do is we're going to be calculating the volume of a rectangular prism. And the way that we are going to do that is, I don't necessarily need us to show using centimeter linking cubes, but I'm going to find the area of the base first. So if this is the base, it's this part here. Okay, that's our base that we're working with, and it's 4.5 meters by 3 meters. Okay, so I'm going to get out my calculator, use my formula. Area of a rectangle is length times width, and so it's going to be 4.5 meters times 3 meters. Get out my calculator. So I have 4.5 times 3, which gives me an area of 13.5 meters squared. Now it's squared because I have two dimensions. I have length and width. So that's the area of the base. Then what I need to do is multiply the area of the base times the height of the shape. So I have volume going to be equaling 13.5 meters squared times 2.0 meters, because that's the height of the shape. And if I take my 13.5, multiply it by 2, I get a total of 27 meters cubed. And the 3 is because I have length, width, and height. Okay, so the volume of my shape here is 27 meters squared. In general, we can simplify this problem because we can just use a formula. So the formula that I can use for rectangular prisms anyway is length times width times height. That's the simplified formula. This is volume of a rectangular prisms. Okay, and so once I've written down my formula, I put in my numbers in place of the letters. So I have 4.5 meters times 3 meters times 2 meters. And when I do that multiplication, just show it to you on a calculator, 4.5 times 3 times 2 gives me 27 meters cubed, again because of the 3, length, width, and height. Okay, so that's the volume of this rectangular prism. Okay, now that's how to do rectangular prisms. When we do triangular prisms, it's a little bit different. And again, what I'm going to do is use the formula for the area of the base, which is a triangle. So I know the formula I need is base times height times 2. But if I want to simplify things, maybe I'll show it to you in 2 different ways first. So if I put in my substitutions, I know that the base is 4 centimeters. I know my height is 5 centimeters. That's what the diagram tells me. And I got to divide that by 2. So that's 20 centimeters squared divided by 2, which equals 10 centimeters squared. Then what I do is I take the area of this blue base, of the base in general, and I multiply it by 2, or by 3 centimeters rather, because that's the height. And when I do that, I get a volume cubed. The volume equals 30 centimeters cubed. Okay. Now I can try a simplified to try and combine a bunch of those steps together. And what I can do for the triangle is I can say volume is going to equal, and I'm going to use these big square brackets. It's my base times height divided by 2 times, I'll use a capital H. And so I have 2 H's here. You'll notice I have the lowercase h for the height of the triangle, and then I have like an uppercase H that I'm deciding to use, which is going to be the height of the prism. Okay? And so when I do that, and when I do my substitutions, I keep the big square brackets, and I have 4 centimeters times 5 centimeters divided by 2 times 3 centimeters. Okay? So this part here is going to tell me the area of the base of the triangle, and then I'm going to multiply it by the height, which is going to give me the volume. So that becomes 20 centimeters squared divided by 2 times 3 centimeters, which is still 10 centimeters squared times 3 centimeters, which equals 30 centimeters cubed. So I've gone from 1, 2, 3, 4, 5, 6 to 1, 2, 3, 4, and then 5. And then even you can probably do all this in one step because it's just division and multiplication, and if you follow order of operations, you just do it all in one step. Okay, so that is a method to calculate the volume of, 2 methods to calculate the volume of not a rectangular prism, a triangular prism. There we go. Sorry I didn't catch up on that. So let's try a bit of a different problem. So this solid is made from centimeter Lincoln cubes, or we are imagining that they are. We're going to determine the dimensions of the figure given the different side lengths. So for the first one, we're going to assume that each of these side lengths is 2 centimeters. Okay, that's really hard to see, but what I'm trying to get across is that the distance, just one is 2 centimeters. Okay, So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that means that my length equals 20 centimeters. If it's 1, 2, 3, 4, 5, 6, it means my height is equal to 12 centimeters. And if I have it this way, 1, 2, 3, 4, 5, 6, 7, that means that my width is equal to 14 centimeters. So these are my three dimensions that I'm working with. So I use my formula, volume equals length times width times height, which equals 20 centimeters times 14 centimeters times 12 centimeters. I get out my calculator. Gives me an overall volume of 3,360 centimeters cubed. Now, if instead of 2 centimeters, I say that each cube is now 5 centimeters long, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means that my length now becomes 50 centimeters. 1, 2, 3, 4, 5, 6 times 5 means it's 30 centimeters, and then 1, 2, 3, 4, 5, 6, 7 times 5 means 35 centimeters. And so again, use my formula, length times width times height, and it becomes 50 centimeters times 35 centimeters times 30 centimeters. I get out my calculator. 50 times 35 times 30, which gives me a grand total of 52,500 centimeters cubed. Don't forget that centimeters cubed for the three dimensions, length, width, and height. Okay, so those are some strategies to solve the volume of rectangular prisms and the volume of triangular prisms. And so I hope you have a great night.